Howdy, PreCal. It's Miss Kosh. I wanted to work through some of that sequence and series introduction that happens in your book, Chapter 8, Section 1. The worksheet that you have to take notes on, it wouldn't print for me. So here we go. So what they're asking us to do on this first one is they're asking us for the first four terms, and then they give us this expression. And so typically what we'll see is we'll write a sequence. We'll find the nth term writing something like this, where we have a sub n, or in my IB world, they like to write u sub n. It can be any, I mean, there are some letters that we use more often than others, but here's your first example. So to find the first four terms, well, we would find the first term by plugging in 1 for n. And so negative 1 to the 1 is going to be a negative 1, and so plus 3 gives us 2. And then our second term, we'd come back to that original equation, and we would now plug in 2. Well, negative 1 squared becomes a positive 1, and this is going to be 4. And hopefully at this point you see that we're just going to oscillate between 2 and 4. So the third term is 3 plus negative 1 cubed. That's a negative 1, so we're at 2. And then a sub 4 is 3 plus negative 1 to the fourth, and so, that's 4. So our first four terms here go positive 2, positive 4, positive 2, positive 4. Fantastic. The next sequence that they had given you in the book, and what I used, is I said b sub n is equal to a negative 1 to the n over 2n minus 1. So if we want the first four terms of that, same idea, we're going to plug in 1, and I get a negative 1 to the 1 over 2 times 1 minus 1. This gives me a negative 1 over 2 minus 1 is 1. So just a negative 1. There we go. Our second term, we come along and say, okay, it's negative 1 squared over 2 times 2 minus 1. This would clean up to be a positive 1 on top, and then this is 4 minus 1 is 3. And there we go. Our third term, same idea. Hopefully you're understanding, you're following this pattern as we go. And so I have a negative 1 on top, and this becomes 6 minus 1 is 5, and there we go. Fourth term is going to behave in a similar way. Maybe you see this pattern, it went negative, positive, negative, so this next one's going to be positive, and then this is a nice little, oh, sorry, you couldn't see, negative, positive, negative, positive. And then I have 1, 3, 5, and so this becomes 7. And if you plug that in, you'll see that I'm right. The third one that they gave us was, they said c sub n. So notice on these I have a sequence of A, a sequence of B, and then this sequence was C. I was just trying to get you used to using different values there. And this was 2 to the n minus 1 over n and an exclamation point. That means n factorial. And so if we were to work, if we're working with factorials, what a factorial does, like say I have 4 factorial, this becomes, we always have, well, that's not always true. In this course, we'll start with an integer, and then we just subtract 1 and go all the way down until we get to 1. And so this is 4 times 3 times 2 times 1, which is 24. So over here, now we're saying, okay, well, our first term, c sub, oh, you know what? I didn't write this down correctly. The example they gave us was n minus 1 factorial. My bad. So the reason they did that is because they said let's start when n equals 0, but typically a sequence would start, the first term is the first term, we plug in 1, so I changed the equation. So that's neither here nor there. So I have 2 to the 1 minus 1 over 1 minus 1 factorial, which looks like this is 2 to the 0 over 0 factorial. Well, what happens here, 0 factorial is defined for us to be 1. So I have a video for my IB kids where I explain that, but we just know that anything to the 0 power is 1, 0 factorial is 1, this first term was 1. Our second term is 2 to the 2 minus 1 over 2 minus 1 factorial. So this is 2 to the first power over 1 factorial. Well, 1 factorial is just 1, 2 to the first is just 2, so 2 over 1, well, 2 over 1 is equal to 2. The third term becomes, we have 2 to the 3 minus 1 over 3 minus 1 factorial, which is 2 squared over 2 factorial. 2 squared is 4, 2 factorial is 2 times 1 is just 2, and that's equal to 2 also. So our fourth term, 2 to the 4 minus 1 over 4 minus 1 factorial, which is equal to 2 to the third over 3 factorial. Well, this becomes 8 divided by 3 factorial is 3 times 2 times 1. That gives me a 4 when I cancel with that over 3. So there are the first 4 terms on the first part of our worksheet. All of these formulas were given to us. These are what we would call explicit formulas, where they tell you explicitly what to do. Maybe that's, oh, there's the other one. What the advantage to this type of formula is if I wanted to find the 100th term, I would just plug in, like if I needed C sub 100, well then this is just going to be 2 to the 99 over 99 factorial. Well, I don't know what that's equal to, but I could plug it in my calculator and see or whatever, but I could find the 100th term pretty easily. The next part of your worksheet, so number 2 in your notes, asks you to find the first 4 terms of these recursive sequences. And so the first one they give you is, they tell you a sub 1 equals 5, and they tell you a sub n equals a sub n minus 1 plus 3. And so what we need to do on this particular problem is, oh, I forgot, I was going to show you calculator stuff. So back over here, one nice thing about our calculator is that I can go to my table feature. So I can go menu, go over to table, and let's say I wanted to do, I don't remember what that problem was for, but okay. Let's say I wanted to do that third one that we had where it was fraction. It was 2 raised to the n minus, oh, not negative, n minus 1 over x minus 1. And do you know where to find factorial? I will show you. I say that. I go to option, and then probability, and then here's that factorial. So there it is. So I can plug this in, and I can go look at my table and find the first however many. Notice those should be the terms that I had gotten a minute ago. And it is. So if you have a explicit formula, the table feature is really great because you can then, if I wanted to, well, let's see what happens if I try and find that 100th term. It's too big. Okay, but that doesn't surprise me too much. But I could find the 20th term. Well, is that one too big? It's big. Well, it's little, actually. It's being the numerator is being divided by a really big denominator. Anyway, I digress. Okay, so that table feature can work really well with your explicit formula. So now we've moved on to a recursive formula. And what this is saying is, well, so if you think about all of the terms of your sequence, you've got your first term, your second term, your third term, your fourth term. Somewhere out here is your nth term. Okay, and the term that came right before the nth term is the n minus 1th term. And the term that comes right after your nth term is the n plus 1th term. And so I like to say in class, I'm not grading your handwriting, but I'm grading your handwriting, because this has to be all that little subscript. So like if we say a sub n minus 1, that is the term that came before the nth term, or I like to say the n minus 1th term, but it's not the same thing. Usually, occasionally this would be the truth, but it's not the same thing as saying that, where it's a sub n minus 1. This takes your nth term, whatever that value is, and then you subtract 1 from it. So like if I had, if I said a sub n was just equal to 2n, so I've got all the even numbers are my sequence here, then a sub 10 would be equal to 2 times 10 would be equal to 20. A sub 10 minus 1, a sub 9 would be equal to 2 times 9. That's a 9. That's a funny looking 9, which is 18. But if I said, okay, a sub 10 minus 1, that would be equal to a sub 10 minus 1 is 19, not 18. Anyway, that just be careful with your notation. So what this is saying, coming back here, what we have is they tell us the first term, and then they say that the nth term, you go to the term right before it, the n minus 1th term, and you add 3. Okay, so on this one, we're going to start with our first term. So a sub 1 is equal to 5. A sub 2, you don't have to write this out every time, but I just want to make sure we're clear on this. A sub 2 would be equal to a sub 2 minus 1 plus 3, which is like saying, okay, well, this is just your first term plus 3. Well, the first term we knew to be 5, so 5 plus 3, a sub 2 is equal to 8. A sub 3 we go to the a sub 2 term and add 3 more, and we're at 11. And a sub 4, we go to the third term and add 3, and we're at 14. Now, our calculator can do this nicely for us. If you just come back to the main setup here, what we can do is we can type in that we started at 5, we hit enter, and then I can just tell it plus 3, and then I can find all these different terms recursively. So it's generating all these terms for me. Isn't that lovely? Okay. The next one, part B, said b sub 1 was equal to 3, and b sub n is equal to 2 times b sub n minus 1 plus 1. Okay, so to do something like that, it's the same idea. To find the second term, well, the first term would be 3. The next term, we're going to take the first term. So to find the second term, we take the first term, multiply it by 2. So 3 times 2 is 6, and then add 1, we're at 7. The next term I'm going to plug in 7, multiply it by 2, 14, plus 1 is now 15. Then I have this one, so 15 times 2 is 30, plus 1 is 31. And this is going to generate the terms of our sequence, or the first 4 terms that we generated recursively. So I can come over here, delete out everything, and say, well, this is 3, and then I'm going to take that answer, multiply it by 2, and add 1, and that should give me the terms of my sequence. The third one on this part of the worksheet, I think, let me look again. Yes, okay. So it said C sub 1 is 1, C sub 2 is 1, and then C sub n is equal to C sub n minus 2 plus C sub n minus 1. So what this is saying is we're going to take, well, the first term is 1, the second term is 1. The third term would be equal to, well, 3 minus 2 is 1, is the first term, plus 3 minus 1 is 2, plus the second term. And this becomes, okay, so the first term was 1 plus 1 is 2. So now the fourth term would be equal to the second term plus the third term. The second term was 1, the third term was 3, so 1 plus 3, well, I lied. 1 plus 2 is 3. The fifth term, we're going to be adding the third term and the fourth term, so the third term and the fourth term, this is going to be 5. And this, ladies and gentlemen, is this has a fancy name. This is the Fibonacci sequence, and so it's 1, 1, 2, 3, 5, oh, there's my comma, 8, and then 13, 21. So what I'm doing here to form that this is Fibonacci, I think it just has one B. Okay, I'm a terrible speller, so go look that up. But it's a dead Italian guy. But basically, we take 2 terms, we add it to get this one. So 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. And that is the Fibonacci sequence. And it's very easy to define if we define it recursively. If you try and define it explicitly, you get root 5s all over the place, and it's really confusing, and I don't know it off the top of my head. Okay, I think I'm going to stop this video here, and I'll make it a second video for the number 3 on your worksheet.